Okay, so lesson 5 is very similar to lesson 4 because we're dividing. But we're going to be rationalizing denominators that are binomials, so you could highlight that. And we talked about that clever way of multiplying conjugates. So conjugate is plus plus, and then the other one is plus minus. This is conjugate. This is difference of squares. So they come in like this. A times a square, and negative ab, and then positive ab, and then negative b times b, which is b squared. The middle terms disappear, and you get this. And this is, when you're doing radicals, this is another clever way of multiplying. So last lesson we did a clever way of multiplying by 1. And this is another clever way of multiplying. I did show you this when we were multiplying. I think it was lesson 3. We're distributing conjugates. So it works out really nicely with squares, obviously, and square roots because they disappear. Okay. And doing this by brute force, it takes forever. But we will do a couple by brute force. So we're going to multiply by 1 in a clever way again. Remember, we multiply by 1. So you start with the exact same question, and then you multiply by a copy. So what are we copying, the bottom or the top? Copy the bottom, and then you notice it's binomial. But we don't copy it exactly. We copy it, but we use the conjugate. So I'll put in blue there. We use the conjugate, which is a word you may or not remember, but for this unit I would memorize it. I would put this on my formula sheet, or not my formula sheet, my study sheet. There's not a lot to memorize this this unit, so commit it to memory and you'll be okay. Alright, so like always with fraction multiplication, we go top to top, bottom to bottom. So let's do the top. We're just going to be distributing a 2. So we get 2 root 5 and 2 root 3. And now the bottom. We could brute force this, or we can just be clever. This is just a difference of 2 squares. So yeah, this is 5 minus 3. Okay. If you don't see it, we'll do it together. Let's just use my pointer, though. I won't write anything. So the first term goes on this first term, and you get root 5 times root 5, which is? What's root 5 times root 5? 5. Use my pointer again. Now this root 5 has to go onto the root 3, right? So you get over here, you get a positive what? Root 15. So just keep that in your head. Got a positive root 15. Now we go to the inside and distribute this 3, and you get a negative root 15. So what happens? They're gone. And then the last one is a negative times a positive. Root 3 times root 3 is? Good. So you get this negative 3 down here. So you get 2 root 5 plus 2 root 3 over 2. And now just like on that quiz, when you divide those guys, and you divide those guys, right? And what's going to happen to these 2's? Cancel. So you get root 5, and then you get another cancel plus root 3. So there's the final answer. So all this junk at the top is exactly the same as this final answer here. And like always, you can always double check with your calculator. So we had a 2 divided by, was it root 5 plus a root 3? Oh, minus, my bad. You guys should have told me. Yeah, you better be sorry. Okay, minus. You see how I copy and pasted the last thing? Do you guys see that? Second, enter. That's entry. For these older calculators, you can copy paste the last line. Okay, and then what was the final answer that we got? Thank you, Doug. square root 5 plus square root 3. And ignoring that thing at the top, you have these two answers, 3.96, 3.96. So that's a good check. That's just a way of checking. On the test, did I do this correctly? Here's a way of checking. Okay, that's not how you're going to answer it, obviously. You never answer with decimals like that, but it's just a self-check. All right. I always like that in math. It's like, how can I use my calculator to make sure I did this properly? Okay. Multiplying by 1 in a clever way, we're going to have root 6 and a 2, root 6 and a 2. What do I put in this time? Opposite of plus? Okay, minus. Okay, so the bottom is superbly easy. Can we just go fast on the bottom now? Six minus 4. Good. You square the first, and you subtract the square of the second. So root 6 is 6. 2 by 2 is 4, and we're subtracting. So it's going to be 2 on the bottom. 6 minus 4. Now on the top, we have, not a difference of 2 squares, but a perfect square. And perfect square trinomials are similar to this, but instead of these canceling, they double up. Okay, so watch what happens over here. You could jot this one down on the top of your page over here. These are perfect squares. And it would be the same if it was minus minus. That would work out too. So foiling this out, you get a times a, which is a squared, and then you get a times b, which is ab. Now what happens on the inside? ba is also ab, and then you get a b squared. So what happened to the middle two terms? They double up, right? They combine, you get the same thing twice, so you have two ABs. Now if you could memorize that, then this situation here is also going to be superbly easy because it's the exact same thing, it's the exact same thing. All right. But I think I'll just brute force it for you guys. Okay, so let's do it with the arrows. Root 6 times root 6 is 6. And then we get, what's the next one? Root 6 times a negative 2. Negative 2 root 6. So we should expect that to happen again on the inside. It's going to happen on the inside here. Negative 2 root 6. And then the last one is positive 4. And what's going to happen to these guys in the middle? We already know what's going to happen. Not cancel out. Did these cancel out? They doubled up. So that's what's happening here. So negative 2 is going to become negative 4. So just fixing what we know. 6 plus 4 is 10. 10 minus 4 root 6 all over 2. Can I keep going on this? Okay, so 10 divided by 2 is 5, and 4 divided by 2 is 2. Final answer. Questions so far? Oh, there's only one page of notes. That is a blessing. Okay, let's do this next one. No questions. Okay. What do I copy at the bottom? Oh, that was a good square root sign. Here, it's better on higher quality on top, okay? Look at that junk. I don't know what that means. There, better. Got a little funny curve to it, but better. Okay, the bottom should be super easy. So it's going to be 1 times 1, and then root x times root x, that's just x, and then we subtract. Okay, so the bottom, always easy like that. Top, this one actually looks so easy. You're just going to distribute a 1, so 1 times 1. And then 1 onto root x, like, oh my gosh. Why was that so easy? I don't know. Do the ones cancel? That's a good question. The answer is no. What do you mean, how do you cancel a 1? Well, you'd have... Oh, this is a good question. This is a good question. You're saying, okay, can I do this? Like, what are you going to try to do this? Like, that doesn't even make sense. You can't do that. Okay, what you're thinking about is good because this is the denominator. The denominator is a binomial. On these other ones, like right here, this denominator is a monomial. So it's very easy to just divide these like this, right? Each one gets divided. But with a binomial like this, you would have to split it. You cannot split that binomial in the bottom. It would be this, 1 over 1 minus x plus root x over 1 minus x. That's the only thing you could do to that. And to me, it looks identical. You know how you add fractions, they have to have the common denominator? That's like that. So I wouldn't worry about this. You don't need to go that far. So anyways, we took a crappy question and turned it into a learning experience. Express with a whole number in the denominator. I don't even know what that means. Root 8 minus root 3 over 4 root 3 minus root 2. Okay. I know because this is the section on rationalizing denominators. So let's make sense of this. Translation? Rational. Rationalize the denominator. That's the translation. I'm pretty sure on the tests it will just say rationalize the denominator. That's what it'll say. Okay? So just make a little note of that. So we have to do a carbon copy but use conjugate. So 4 root 3 plus a root 2. 4 root 3 plus a root 2. The bottom will be easy. The top will be nasty. Can you guys predict that like I just did? The bottom will be nice. The top is going to be like less than 3, where it's like 2 random binomials we're multiplying. Okay, so let's just do the bottom. So I feel like just using the difference of squares formula. So I'm just going to do that for the first step, for the bottom. They're just a little bit more complex, so I'm just not going to go fast. You know, this might be a strategy you might want to use. Just use the difference of squares formula. Now on the top, I'm going to just brute force this, so root 8 is going to go onto both. So it looks like a 4 and a root 24. And root 16. So there's the first 2. And like it's just going to look kind of ugly at first because I didn't center the bottom, but that's okay. Now the second term, or the inside, so negative and a root 9. Negative 4 and a root 9, my bad. Negative 4 and a root 9. And then the last one is a negative root 6. Okay, any questions before I keep going? Kyle, you got that one? Fred, you got that? Okay, so we cool on this? Okay. Let's put my pointer on some easy ones. What's this? 4, right? What's this one? 3 by 4 will be, all this will be negative 12. So pretty easy in here. Can I do anything with 6? And the 24 has what in there? A 4? Is there a better one? No. 4, right? Okay, so let's do this. The bottom will be fixed now. So it'll be 16 times 3 minus 2. So that's the bottom. when you square, the 4 gets squared, the root 3 gets squared. So don't forget to do both. Now on the top, root 24, I'm just gonna like edit it on the page. So 24 is 4 and 6. This 4 is gonna come out with a 2. That'll become, so I need to get rid of that stupid 4 down there. And I'm gonna have 8 out there with a root 6 left over. Anybody can plan ahead what's gonna happen with that root 6? Later on, we're going to have to combine with that one, right? Okay, the root 16 is going to be 4. Now this root 9 is going to become 3, and that's going to come together as minus 12. And then we have a minus root 6 still. Okay. 4 minus 12 is negative 8. That's dealt with. 8 minus 1, 7 root 6. Okay, 16 times 3, 48 minus 2, 46. And then, do you keep going on that? I wouldn't. Why wouldn't I? Huh? Well, 7's prime, so 7's not gonna. The 8 and 46, those could reduce if you wanted. You could both divide by 2. But I think it's pretty good right there. Yeah, that's as far as you need to go. Okay, last question on the bottom. I don't know why I didn't use all this space. I thought there was another question or something. Look at this. It's like, oh my gosh. Oh, area of a trapezoid. Physics students know that formula. We use the area of trapezoid formula in Physics 20 to develop the kinematics equations. Don't even talk like that. Ooh, you're scared. Do you remember that? What? The VT graph? Oh my gosh. This is VI and VF, and this is time. Oh, you better know physics. Take physics, you know how to use the area of trapezoid formula to your benefit. Anyways, so nerdy in here. I love it. Okay, what we got here? Blah, 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 trapezoid formula. Okay, put a box around that. A and B are lengths of the parallel sides, and H is the shortest distance between the sides. Okay. If the area of a trapezoid is 20, so we could just, let's just jot down that formula. 1/2 H A plus B. Okay, so where do I put this 20? Thank you. So this becomes 20. What else did they give us? The parallel sides are root 6 and root 5. And then they're asking us probably to find H. Okay, so root 6 plus root 5. Okay, an exercise in algebra. Physics 20 students. What do I do? You guys should have this. Give up? No. Okay, math students. See if we can show these physics students up. What's up? Put it in your graph, find y1, y2 intersect. That's the -2 strategy. Straight up. In -1, you gotta know your algebra, man. Okay, well, first of all, I would just move that half. I would get rid of that thing in a second. Huh? No, you don't want to divide by 20. You want to get rid of the stuff on the right. See how I put a box around the unknown? That's the unknown. You got to unlock that sucker. So the 1/2's got to get out of there, and this whole bracket's got to get out of there. Yes. Yes. So 2's in the bottom, right? Everybody look at that. 2's in the bottom on the right. So where does it need to go on the left? Okay, so you got 40 equals h root 6 plus root 5. Any questions on that? Could you have divided by a half on both sides? And dividing by a half is the same as multiplying by 2. Okay. Okay, now how do I isolate for h? And people that are like lost, this is no different than this situation here. How do you solve this in junior high? Divide by 5, divide by 5. That's exactly what's happening here. It's going to divide by those brackets, right? Get this. Okay, so let's divide by this. That's gone. And over here we have this. So we've isolated for h. Over here I'm just going to rewrite it. So h is on the left, and I got 40 over root 6 plus root 5. And then, of course, we read the question. It says answer with rational denominator. Okay, times conjugate. Daoud's 2 steps ahead of us. So let's do this. I'm copying the bottom but switching the sign. It looks like the bottom is going to be superbly easy. What is it? 6 minus 5. So it's just going to be all over 1. So there is no denominator. The denominator doesn't need to be written. It's just going to be 1. So the answer is just the numerator. So it's just this stuff in yellow. Distribute, good man. So good, 40 root 6 minus 40 root 5, and that's it. That's your final answer. I'll just put numerator, numerator, and the numerator is right here. Oh, and don't forget the centimeters. Kidding. This is math class, not measurement class. Only in math 10, buddy. All right, good luck with your homework.